Okay, the lesson that we're going to focus on today is about graphing and linear functions. So for many of you, this may be a complete review, which is great. So do as much as you need to refine and to make sure that you remember everything you need to know about graphing linear functions. All right, for some of you, this might be new. All right, but I'm going to go through everything as if you don't know something. So there may be times where you can pause the video or fast forward and move on. All right, so we're going to talk about 4 different forms of a linear function and one that is not a function. All right, and so that the expectation is that when you see the forms, you're able to recognize them and be able to graph them quickly and efficiently. So now the 4 forms plus the non-function will be the vertical line, which is x equals a, and that is the one that is not a function. Point slope form, which is y equals m times the quantity x minus x1 plus y1. Slope intercept form, which is y equals mx plus b. A horizontal line, which is y equals b, and then standard form, which is ax plus by equals c. Now what I want you to realize is that slope intercept form and horizontal line, y equals b, those 2 forms are just a consequence or a simplification of our point slope form. All right, well, let's look at vertical lines. So here's some details that you need to keep in mind. The first is that a vertical line is not a function. All right, we obviously have multiple points for one input. All right, it is a vertical line, so therefore it obviously fails the vertical line test. If we describe the slope or rate of change of vertical line, we say it is undefined. All right, vertical lines will have one x-intercept, all right, and will not have a y-intercept unless it is the line x equals 0. All right, so let's just look at some examples here. All right, now, don't make this harder than it is. All right, this tells us that x has to be -4. So all we know is that for whatever point I pick, the x-coordinate has to be -4. And I just want to pick 2 or 3 points and then draw the line. So here's -4, 2, -4, 6, -4, -4. So as long as my points have -4 as the x-coordinate, then I'm good, and I can just go ahead and draw our line. So here would be, all right, x equals, all right, -4. All right, now for x equals 5, I just need every x-coordinate to be 5. All right, well, here's 5, 0. Oh, let me try to do that again. Let me go back to, all right, let's see, where do I want here? Let's go back to this. What did I do here? All right, so let's go back to that. There we go. Maybe that's what I want. All right, so I think we're going to go a little bit smaller here. Okay, so there's 5, 0. There we go. All right, 5, 3, 5, 6. All right, and so now we can draw our line. So that is, all right, our line, x equals 5, just like that. All right, so go ahead and see if you can sketch x equal to 9 real quick. Just go ahead and pause, all right, the video, sketch that real quick, and then turn it on. Let's see how you do. Okay, let's do x equals 9. All right, so hopefully you have a line, maybe a little straighter than mine, but it should look something like this. So there's x equals 9. And that's all you have to do to graph a vertical line. All right, so now let's talk about point slope form. Now, we get point slope form from manipulating our slope equation here, all right, which many of you are familiar with. So our slope, or m, is equal to y minus y1 over x minus x1. You may also be familiar with it. You may see it as y2 over y1 and x2 minus x1, and that means the same thing. All right, but just for what we are going to do, we're going to have y minus y1 and x minus x1. All right, so to get to slope intercept form, what I'm going to do is treat this as a proportion, and I'm going to remember that m is really over 1. And so one of our properties of proportion is that I can multiply numerator to denominator here, and that would equal to numerator to denominator here. So if I do that, I get y minus y1 from this product here, all right, equals m times the quantity x minus x1. All right, and that's just from cross multiplying the proportion from our slope formula. Now, most of you will see point slope form like this. All right, however, I talk about it more in a function form where we move this y1 term to the right hand side, so it looks something like this. I'm just going to add y1 to both sides. So when I talk about slope, point slope form, I talk about it more in this form, all right? But these guys are both equivalent. All right, but I just talk about it this way. Then it's a little bit more consistent with some of the other forms that we're going to talk about with our other functions. All right, now let's talk about what all this means. All right, m, all right, is obviously our slope, all right, of our line, just like it would have been up here. Now, what we need to know is that this x1, y1, all right, is a point on the line. Okay, so when I see this, I should automatically know one point on the line, and then to generate my other points, I'm going to use my slope, all right, to generate those points and then to draw my line. So just a couple of details here. One, know that the negative, all right, that we see here is from our slope formula, all right, because we're subtracting those two x coordinates. So when I write it here, all right, if it's a negative x1, it's really a positive x1, all right. But if this were to be a positive, so x plus 2, for example, we really need to know that this is going to be a negative x value, because a negative times a negative will make that a positive. And if that seems a bit fuzzy right now, all right, wait till you see an example, all right, and it'll maybe make better sense to you. All right, so let's go ahead and just do an example or two, all right, after we go through here. So, all right, we said 1 is that slope or rate of change. x1, y1 is any point on the line. Now, something in point slope form will have one y-intercept and one x-intercept. Okay, if m is positive, the function is increasing, so it should be going uphill from left to right. If our m, or slope, is negative, we say the function is decreasing, and it should be going downhill from left to right. All right, so now let's look at what we have. So the first thing I want to do when I have point slope form is I want to identify the point on the line. So when I look here, here's my x1. So my x1 is 5. My y1 is the number out here, which is negative 3. So I'm going to plot that point first. So 5, negative 3. So 1, 2, 3, 4, 5, and negative 3. Now, the next thing I want to do is identify my slope, which in this case is 3. Now remember, all slopes are ratios. And so if it's a whole number, the denominator is 1. So this is the change in y over the change in x. All right, since this is a positive 3, that means I want to go up 3. And since the 1 is positive, I'm going to go to the right one. Up 3 again, to the right one. Now, if I reverse that, all right, my slope is positive, so the other way I could think about this is negative 3 over negative 1. So I would go down 3 and to the back 1. And so sometimes you may have to do that depending on how much room you have on your graph, right, to generate your points. Okay, so now let's look at our second example here. So the first thing I want to do is figure out what my x1, y1 would be. Now notice, this is a positive 6. All right, that negative is part of the formula. So a negative times a negative create this positive, so that must have meant that our x1 was a negative 6. And then once again, our y1 is this number, so our initial point is negative 6, negative 2, which is right here. Now I'm going to identify our slope, which in this case is negative 2/3. And remember, you can put the negative either in the numerator or the denominator. It just has to be in one place and not both. But I just always put it with my numerator just to make things consistent. All right, so that means I'm going to go down 2 and then to the right 1, 2, 3. I can go to the down 2 and then to the right 1, 2, 3. We generally want at least 3 points. Now notice, if I wanted to go in the opposite direction, I would go up 2 and back 3, 1, 2, 3, and notice that falls into line with our other points here. There we go. All right, so hopefully you're very good at drawing that line. A little shaky here. So what I'd like you to do now, all right, is I'm going to give you an example, all right, slide here with 2 different lines, and I would like you to try to sketch both of those, all right, on your own. So pause the video, sketch those 2 lines, all right, then turn the video on and let's see how you did. All right, so let's look at our first guy here. All right, so a couple of details here. All right, one, this is still our x1, so that is negative 4. And notice there's no number out here, which means y1 has to be 0. So our first point that we're going to graph is negative 4, 0. Now, our slope is the number being multiplied in front of the parenthesis here, which in this case is negative 1. And remember, we're going to add that 1 to the denominator. So I'm going to go down 1 to the right 1, down 1 to the right 1, and generate my line. So there you go. And that's what you should have. All right, if we move to our second example here, all right, so negative 6, 5 should have been, All right, your x1, y1, so negative 6, 1, 2, 3, 4, 5, right there. All right, and then the slope is 4/5. So I'm going to go up 1, 2, 3, 4 over 1, 2, 3, 4, 5. Okay, now notice if I try to reverse this, 1, 2, 3, 4, and then back 1, 2, 3, 4, and I go off the graph a little bit, but I can kind of sketch that, and there we go. And that is graphing in point slope form. All right, so let's take a look at our next form, which is slope-intercept form. All right, now slope-intercept form is y equals mx plus b, where m is the rate of change, so that's still the slope like we were just talking about, but b is the y-intercept. Now what I want you to realize is that this is just a simplified version of our point-slope form. All right, so all the characteristics we just described with point-slope form we're going to carry through with slope-intercept form. So what I want you to see, all right, is if I look at this, all right, and the way we get to slope-intercept form is that we just follow distributive property first. So I'm going to distribute to the two terms inside my parentheses. So that's going to be negative 2/3 x. Negative 2/3 times 6 is negative 4. And then I still have my term out here, so I'm going to bring that down. And then the last thing I need to do is just combine my like terms here. So negative 2/3 x minus 6. All right, so notice the negative 2/3 is my rate of change here, and it's still the negative 2/3 here. Right? We have just simplified to get rid of the parentheses. Now, what we should realize is that what happens here, and the reason why this will always be our y-intercept, is what we know is that for every y-intercept, all right, x is 0. So notice if I plug 0 in here, and I'm going to do it just in general terms so you can see that this would work for everything. All right, this would be y equals our slope times 0 every time. So what am I going to be left with? Y equals b. So that b is going to be our y-intercept because every time we plug in 0 to solve, it's going to eliminate the term with our slope. All right, so what this means graphically is our initial point will always be the y-intercept, and then we just generate our points using our slope, similar to what we just did on the prior examples. All right, so let's look at what we have here. Okay, so here's our first example. So I see that this is y equals mx plus b. So I see that this is b, so that means my initial point is 0, negative 6. So I'm going to plot that guy right there. Now once again, I identify my slope, m equals 5/2. All right, so my change in y over my change in x. So from my initial point, which happens to be my y-intercept this time, I'm going to go up 1, 2, 3, 4, 5 to the right 2, then up 1, 2, 3, 4, 5 to the right 2. Oh, that was the right one, so let's get rid of that point and let's actually go all the way over it. There we go. And notice I knew right away because it did not fall in line with my first 2 points, which is why we do 3 points instead of 2 points, just in case you miscount somewhere. And then there's our line. Okay, now let's look at our guy here. Now once again, I need to find my y-intercept. Well, notice there is no b. Okay, if there is no b, that's telling you that it goes through the point 0, 0. So I'm going to go through this guy right here. I identify my slope, which is negative 5, and remember, if it's a whole number, we're always going to put it over 1. So from the origin, or 0, 0, I'm going to go down 1, 2, 3, 4, 5, and over 1. All right, now notice I may want to reverse it this time, so I'm going to go up 1, 2, 3, 4, 5, and then back 1, all right, to create my line. All right, and that's graphing in slope-intercept form. All right, so once again, I'm going to give you a slide with a couple of examples. So what I'd like you to do right now is go ahead and pause the video, all right, and try those on your own. All right, so let's go through this very quickly. All right, so right here our y-intercept is 1. All right, so 0, 1. So that's our initial point, and our slope is negative 1/4. So from our initial point, I'm going to go down 1 and to the right 4, down 1 and to the right 4. All right, and then we should come up with this guy right here. All right, let's move on to the second example. So 0, 8 is your initial point. That would be our y-intercept. Our slope is 4. And once again, if it's a whole number, I'm going to put it over 1. Now notice, 1, 2, 3, 4 over 1. I kind of run out of room up here, so I have to reverse it maybe to get my third point. All right, 1, 2, 3, 4, and then 1. Down 1, 2, 3, 4, and back one again. So if you run out of room, you will in fact have to reverse your slope, all right, to generate enough points, all right, to graph your line. And there you go. There's a couple of slope-intercept form lines. All right, moving forward again. Horizontal lines. Once again, this is just a simplified form. All right. Now, what happens though, if we have a horizontal line, that means I am not going up and I am not going down. So our rate of change is 0. Okay, so we say this function has a constant value. It will have one y-intercept, and it will not have an x-intercept unless it's y equals 0. Then it will be the whole x-axis. All right, so let's see what happens. All right, so notice if our rate of change is 0, all right, okay, that would be y equals 0, and then times all of this, right? Okay, and notice no matter what this is always going to be 0, which is going to leave us y equals that y1 value. Okay, so then this is going to be, all right, the value that we're going to use to generate our points. And every point will have to have this value, all right, as its y coordinate. All right, so now once again, let's just go ahead and look at some examples. All right, so graphing horizontal lines. So we have y equals to 8. So just like on our vertical lines, what this is telling us is that we don't care what points we generate, just that the points all have to have 8, all right, as their y coordinate. So 0, 8 is an easy one to do. All right, I could do 5, 8 out here. I could do negative 1, 8, and I just want to generate 3 points. And notice every point on this line has a y value of 8, all right, in the coordinate point. Okay, so y equals negative 2. Once again, we don't care what 3 points we graph, just that all the y coordinates are negative 2. So we have negative 6, negative 2, negative 7, negative 2, negative 8, negative 2. And I can see that that just creates this horizontal line right here. You can see that, whoa, got a little off there. See that that gives us a y-intercept of negative 2 as well. And there we go. All right, so just real quick, go ahead and pause the video and see if you can sketch y equals negative 7. All right, here we go. Let me just scroll down a little bit. So y equals negative 7 should be this line right here. All right, so there you go. Now, our final form, all right, is standard form. Ax plus by equals c. I'm going to show you 2 different ways to graph this. Now, I do not personally care which way you use. All right, and what you'll learn is that there are some ways that might be quicker, more efficient in certain situations based on what we are looking for or what we want to do. All right, but I would be consistent, all right, in how you approach this. So if you want to use the intercept form, which I'll show you, or if you want to solve for y, which I'll show you, that's fine. All right, if you know both, that's even better. But definitely make sure you understand one way, all right, of graphing things in standard form. All right, so let me show you the first way that we can do this. Okay, so the first thing that we can do is make this, all right, look like one of the forms we've already talked about, which is our slope-intercept form. So we can make it look like y equals mx plus b. So notice to do that, we have to isolate the y, okay, by itself. Okay, so what I want to do is if there's any extra terms with the y, I want to move them to the opposite side of the equation. So I'm going to start by subtracting, all right, 3x from both sides. So I'm going to have 0 here. That's negative 4y equals. Now, remember, these are not like terms, so I can't combine them. And that makes sense, so I know I should have one x term and one number term. So just to make it consistent, I'm going to write the x term first, and then I'm going to write the number term. Now, once again, notice y has a coefficient of 1. So if I have any other number here, I need to divide everything by that number. So all 3 terms in this case. All right, so that is 1. So it leaves us 1y, which is what we want. That's now a match up here. Now remember, we think of slope as a fraction, so if I get a fraction here, I just want to reduce it to lowest terms. So negative 3 over negative 4 reduces just to positive 3 over 4. We have our x, and then just work out whatever fact you have here. So in this case, it's negative 4. So now what you see, all right, is slope-intercept form, and we would graph this just like we did prior. So I know my y-intercept is 0, negative 4, so I'm going to come put a point there. And then we know our slope is 3 over 4. So I need the change in y is up 3. The change in x is to the right 4. So 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. And looky there. There it is. just like that. So if we manipulate that to slope-intercept form, perfect. We can just roll with what we already know. All right, so what I'd like you to do now is, once again, just go ahead and pause the video, and I would like you to solve for y and get this equation in slope-intercept form and sketch your graph. Okay, all right, so what I'm going to do is just quickly go through what you should have done. So the first step, okay, is I'm going to subtract my 5x from both sides. So I'm going to get 0 here, and then 10y equals, and once again, all right, I'm always going to write my x term, all right, first to help me match my slope-intercept form. Then I'm going to divide by whatever coefficient is in front of y. All right, so that's 1. Now, notice this reduces to negative 1/2 x, and the negative 3 divided by 10 is negative, or negative 30 divided by 10 is negative 3. So once again, your y-intercept was 0, negative 3, right there, and then your slope is negative 1/2. So I'm going to go down 1 to the right 2, down 1 to the right 2. All right, and there it is. Perfect. All right, so now the second way of doing this problem. All right, and this is a little bit quicker, but it may not be as accurate sometimes, and I'll explain to you why. So the second thing we can do when we're in standard form is, what I want to do is I'm going to find my x-intercept, all right, which I know is going to be something 0, because I know y is always 0 for an x-intercept. And then I'm going to solve for my y-intercept, which I know is going to be 0 something. And then I'm just going to use these 2 points, all right, to plot, or excuse me, plot these 2 points to graph my line. All right. So now this is why I say it's a little bit quicker, because all I have to do to find my x-intercept is plug 0 in for y. All right. So if I do that, I'm going to have 3x minus 4. I plug 0 in for y, and notice this is going to be 0. So I get 3x equals 16. I can divide by 3. And what I see is that x is, and this is why I said it could be a little less accurate, because if we start getting some decimal answers for our intercepts, it may not be as accurate when you graph, because I'm going to have to estimate. So notice this is going to be 5.3 repeating. All right, so there's my x-intercept. And so 5.3, all right, so this is where it's kind of right in here, right? Okay, so now if we look for our y-intercept, okay, it's a very similar process. I just plug 0 in for x. So 3 times 0 minus 4y equals 16. This is 0, so I have negative 4y equals 16. Divide by negative 4, and I can see that my y-intercept is negative 4. All right, so 0, negative 4 is my y-intercept. And there we go. And there's my line. All right, and if I just kind of flip back, let's see, not that one, not that one, you can see that we get the same line here, all right, from either form. Okay, so I think this is a lot quicker, but once again, if you get some decimal answers for your intercepts, your line may not be quite as accurate. All right, so now, all right, you just did this one by solving for y. So what I'd like you to do is, once again, just go ahead and pause the video. All right, solve for the x and y intercept. All right, graph your line, and it should match, all right, your prior problem. All right, so now let's just go ahead and once again, if I'm looking for an x-intercept, all right, I know it's going to be something 0. And if I'm looking for a y-intercept, I know it's going to be 0 something. So I'm going to go ahead and just plug 0 in for y here. So I get 5x plus 10 times 0 equals negative 30. So 5x equals negative 30. Divide by 5, x equals negative 6. And there's our x-intercept, which would be this guy right here. All right, so for our y-intercept, I'm going to plug 0 in for x. And get that. This is 0, so I'm left with 10y equals negative 30. Divide by 10, so y equals negative 3. All right, and so that means that's our y-intercept right there. And so then if I draw our line, this is what we get. All right, so now that kind of reviews everything you should be able to do with graphing a line. All right, so what you should be able to do now is there's a packet on graphing lines, and it graphs all the different forms we just discussed. All right, so now, all right, you should do that. Let me know if you have questions. All right, see you in class.